Okay, I'll be going through this P5 weighted assessment paper. It's a 2023 Nanyang primary paper. Okay, so I'll be going through every question. Now, do take note that this whole paper, you're not allowed to use the calculator. So this is to practice and prepare you for your paper 1 exams. All right, so let's look at the first question. So find the value of 6,400,000 divided by 400. Okay, so when you have a division like that which involves numbers with many zeros, the quick way to do this without the calculator is to find a common number of zeros between the two numbers. Okay, so if you notice that the two numbers, there are a common set of two zeros here. Okay, so 400 has two zeros and the 6,400,000 has the two zeros there also. All right, so what we're going to do is we're just going to take away these two zeros. Now, you can only do this in a division. Okay, so do take note. So only division, then you can take away the common set of zeros between the two numbers. So what's left now is basically your 64,000, three zeros left, right, for the first number, and dividing it by 4. Okay, so if you do your long division for this, you will realize that the answer will be number 3, 16,000. So when you do long division, the quick way is to do 64 divided by 4. Okay, 64 divided by 4, which gives us 16. Then you just need to add back the 3 zeros behind the 16. Okay, this is how you can do the long division more quickly, more efficiently. Okay, I'll be moving on to question 2. So question 2, we have this long string of operations, long string of numbers that involves many operations. So notice you have a mix of subtraction, you have division, you have multiplication, and then you have a set of brackets also. Okay, so based on your order of operations, all right, your brackets come first. Okay, brackets is the priority. The next one will be your division or multiplication. Okay, and lastly will be your addition or subtraction. So take note, division and multiplication has the same rank. Okay, how do I know which one to do first, divide or times first? It depends which one comes first, starting from the left-hand side. So when you read numbers, you start reading from the left. In this case, you see if times come first, then you have to settle times. You cannot go and do this division first. No. Okay. Then of course, plus and minus also same ranking. All right. So the top priority is to always settle the brackets first. So in this case, I see that in my brackets, I have 24 minus 8 divided by 2. Now, if I focus on the bracket first, let me just highlight this. If I focus on this alone, notice that again, inside this, I have a mix. Okay, so I have minus and division, both. So which one to do first? Again, based on the rank here, I know that I have to settle the divide first. So I need to do the divide, 8 divided by 2 first in the bracket. Okay, so 8 divided by 2, it's a 4. And then now you can settle the subtraction inside the bracket. So 24 minus 4. So notice this is how I present it neatly. Okay, to make sure I condense it step by step. So 24 minus 4, that gives us a 20. All right. Now, the bracket settled already. Now, back to the left-hand side, the most left-hand side. Notice that I have a multiplication here to work on. 2 times 24. Okay, that will give us 48. And notice then here I have a division also. Okay, so should I do 48 minus 20 first or 20 divide by 4 first? So based on what we just discussed earlier here, of course, you have to settle this one first lah. Okay, so the 20 divide by 4 first. So this actually gives us 48 minus, I bring down the minus sign, 20 divided by 4 will be 5. Okay, so this will be a 43. So the answer will be number 3. All right. Okay, for the next one, find the value of 6 multiplied by 4 over 9. Okay, now, so 6 times 4 over 9, how do we do this? Now, I'm going to show you two methods. All right, so the first method, as some of you have learned before, is the diagonal cancellation method. Okay, so I call it diagonal cancellation because you're looking at the numbers diagonally, 6 and 9. All right, so how do you interpret the 6? Now, 6 itself, if you're not comfortable with seeing it this way, you can rewrite 6 as 6 over 1. Right, so 6 is 6 over 1 as a fraction. So then diagonally, if you want to do the cancellation, this is how I check. 6 and 9. Compare 6 and 9 to see if they both can divide away by a certain common number. All right, so you notice actually 6 and 9 both can divide by 3. Okay, so since 6 and 9 both can divide by 3, I am going to divide 3 away from each of them. So 6 divided by 3 gives us a 2. 9 divided by 3 gives us a 3. Right? And the next one will be 4 and 1. 4 and 1 actually there's nothing really in common to divide away. Even if you do it's just dividing by 1, which doesn't really have any impact here. Okay, so once this is done, actually there's nothing else to do now. The only thing left to do is to take your top, multiply by the top, bottom, multiply by bottom. So 2 times 4, that will be a 8. 1 times 3, that will be a 3. Okay, so as you see, based on our options, the answer would be number 4. All right, so answer is number 4. Now I'll show you another way to do this. So another way some students would consider doing is, based on this, they straight away take top times top, bottom times bottom. That's fine also, but you will realize that the answer is not, it will not be the simplest form. Okay, so this was 6 times 4 is 24, 1 times 9 is 9. So if you divide 3 away from each of them, simplify 8 over 3. So both methods still give you the same answer, just that of course, the more efficient way to doing this is of course the first method. It's a lot faster and you avoid working with huge numbers at the end of the multiplication. So that's the good thing about using the first method. Okay, so this diagonal cancellation, please learn this. All right, you will need to pick this up. Okay, we will go on to question 4. Okay, question 4. So there were 5 liters of orange juice in the fridge. John drank 2 liters of the juice, and Paul drank 2/5 as much orange juice as John. How much orange juice was left in the fridge? Okay, so in this case, now we have this 2 over 5 fraction here. Take note, this 2 over 5 is units comparison between the two guys. Okay, so Paul drank 2/5 as much as John. That means 2 units is drank by Paul, 5 units is drank by John. All right, so this is how we interpret a fractional statement like this. Now, and the thing is, I already know that John drank 2 liters. If you relate this back to the previous sentence here, this would be helpful. Because I also know that John drank 5U, and that also means this 5U that he drank is the 2 liters of juice. So straight away, I can write that down. Of course, you will go on to work out 1 unit. Okay, now be careful for this. To find 1 unit, it's not 5 divided by 2. In fact, it will be 2 liters divided by 5. All right, so it's left side. You notice one quick way to help you understand this is 5 divide by 5 to give you 1. So right hand side must do the same, must also perform divide by 5 to the 2 here. Okay, so 2 liters divided by 5. Do not need to change to milliliters. Please leave it as liters, as you notice that all the options here are all shown in liters. So what this question is testing you is on the relationship between a division and a fraction. So you have to be aware that a division is actually a fraction itself. So 2 divided by 5 means 2 over 5 liters. Okay, so this is how uh we this is how we express the division as a fraction on its own without having to convert to milliliters also. Okay, so 1 unit, we have it there. Now let's find out how much Paul drank. We definitely need that because later you need to find out left. Okay, so let me just write down Paul. This is for 2 units. So 2 units will be 2/5 liter multiplied by 2. Okay, and to do the multiplication is a bit like the previous question. Check if there's any cancellation to perform for this. But in this case, 5 and 2, nothing in common. So straight away, just top multiply by the top. Bottom is a 1, so 1 times 5. Okay, so this gives us 4 over 5 liters. All right, now since we need the left, let's work out the total that they drank first. Okay, so total drank will be what Paul drank plus what John drank, and I know John drank 2 liters from the question given. So together, if you add this up, this will be 2 and 4/5 liters that they have drank, which means that now I can work out the leftover. Okay, so the leftover would be simply using the total at first, subtracting away what they drank. Okay, so this is a P4 what's the subtraction of fractions that you have learned before. A whole number, when you minus a mixed number, take note, you need to re-express the whole number as a mixed number first before you can do the subtraction. So the 5 itself, you can re-express it as 4 wholes and 5 over 5. Basically, I'm separating out one whole. 5 over 5 is one whole. I take out one whole and re-express in this manner. When I take out one whole, the whole number left here is 4 wholes. Okay, so this is how we re-express that, right? Now we can safely subtract. So 4 minus 2, 2. 5 minus 4 is 1 over 5 liters. So this is your answer, number 1. Okay, let's move on to question 5. So question 5, we see a string of numbers here, and they say the first 22 numbers is a number pattern. It's a pattern. So pattern means there will be a repeating set of objects or numbers that always repeats in the same sequence. Okay. Find the sum of the first 88 numbers. All right. So this kind of question, we have to apply this thing called the grouping concept. Okay. So apply your grouping concept to solve this. Now, which means that first, you need to identify what goes into one group first. You need to study through the list of numbers to determine your one group. Okay, so let's figure that out. So if we look at that, we have the 5, 5, 0, 3, 4, 5, 0, 3, 4, 5, 0, then 5, 0, 3, 4, 5, 0, 5, 0, 3, 4, 5, 0. So notice that the one group is actually your here, 5, 0, 3, 4, 5, 0. Okay, then the next set also same thing, 5, 0, 3, 4, 5, 0, and so on. So this group keeps repeating. All right, so this is how our one group looks like. Now, and of course, when you do grouping question, your aim is always to find out how many groups are there inside the 88 numbers. Okay, so of course, you're not going to write this until you reach the 88th number, all right? You don't have so much time in exams. So that's why your grouping here is to help you to be more efficient to solve this question. So first, let's understand one group has how many numbers first. As we can see, one group, there are 6 numbers. All right. Now, and of course, since I want to know what are in the first 88 numbers, that means I can work out the number of groups inside these 88 numbers. All right. And to work out the number of groups simply by using your 88 divide by 6 in one group. Okay, so divide by 6 in one group. Now, if you do your long division for this, you will realize that you will end up with a 14 remainder 4. All right, 14 are 4. So that means this 14 will be 14 of such groups, one after another, 14 groups placed beside each other, whereas the remainder 4 is actually referring to the remainder 4 numbers. Okay, so I'm just going to write that down. These are the remainder 4 numbers after the existence of 14 groups. Okay, so basically it's the first 4 numbers in line after the 14 groups have been placed. So first 4 numbers after the 14 groups. Okay, but these first 4 numbers, I wouldn't say they are like the 15th group because they only exist as 4 numbers, so they cannot be another one group itself. Okay, so it's basically just 4 individual numbers on their own. So what are these first 4 numbers? So if you look at the sequence, the first 4 numbers will be 5, 0, 3, 4. Correct? If you look at after the group, same thing, 5, 0, 3, 4. So your first 4 numbers is this. Okay, so I'm just a bit more specific. Write this down first. All right. Now, if you look back at the question, we are interested in the sum. Okay, so since we're interested in the sum, we should first find out what is the sum of the 14 groups that I figure out here first, which also means I need the sum in one group first. We definitely need this before you can find the sum in 14 groups later. Okay, so what is the sum in one group? Easy, just need to add the numbers up. 5, 0, 3, 4, 5, 0. Just add them up together. Okay. So if you calculate this, you'll realize it's a 17, which means I can go on to find the sum in the 14 groups now. So 14 groups basically is 14 times 17. So the sum in these 14 groups will be 238. All right. Now, but that's not all. Remember, we have the first four numbers to consider that exist after these 14 groups because these first four numbers still belongs to these 88 numbers. They are still inside these 88 numbers. So the first four numbers will be 5034. We have to add those in as well. So your 238, you're going to plus that 5, plus 0, plus 3. Okay, and of course, plus the 4. If you add this together, you will get a 250. So this is your answer, option 2. Okay, so moving on to section B, question 6. Write 809,007 in numerals. Okay, so we have 809,000. So 1,000, there must be 3 places behind the 809. All right, so 809 will be 809. So with another 3 places, we start to fill up the rest of the numbers. And 7, so 7 will be in the ones place. All right, which means the middle 2 there will be a 0. Okay, so that's it. Next will be find the value of 46 divided by 8. Express your answer as a mixed number. Now, since they want a mixed number means we should be expecting a fraction. And that means, remember from section A earlier, I did discuss that the division and a fraction are essentially the same thing. All right, it's just how we express it in the form of one as compared to another. So finding the value of 46 divided by 8, it's if I write it as a fraction, it's the same as 46 over 8. Okay, and of course, you can now re-express it as a mixed number since this is an improper fraction. First one is improper, so now mixed number will be 5 wholes and this will be 6 on top. All right, and of course, you can go on to simplify this, 5 wholes and 3 quarters. All right. Now, next will be express 3 wholes and 1 over 200 as a decimal. So recall back from your P4 work, when you express fractions as a decimal, the very first thing to check is to see whether the denominators are they 10, 100, or 1000. If they are not, see whether you can somehow convert them to these three numbers. Okay, so we see a 200 here. So 200, the next biggest that I can convert to will be 1000. All right, and you notice 200, you can easily convert to 1000, not an issue. Why? Because I can times 5 times 5. Okay, so 3 wholes and 5 over 1000. And of course, you can re-express it as a decimal. So the 3 will definitely be before the decimal point. All right, 5 over 1000. So your 5 will be in the thousandth place. That means the third decimal place. If it's the third decimal place, means in front of it, in front of that 5, we'll have 2 zeros. Okay, so this is your answer, 3.005. Right. Okay, next question, question 9. Mr. Tan saves $1,500 each month. How much does he save in 30 years? All right, so 1 month, okay, 1 month is $1,500. Now, before I go on to do 30 years, maybe what would be good is to settle 1 year first. All right. And as we all know, 1 year has 12 months. So simply 1,500 times 12. Now, since this is a no calculator question, all right, what you can do to do the multiplication more quickly, more efficiently, will be to perform 15 times 12. Okay, you perform 15 times 12 in your 2-digit multiplication. Then you add back the 2 zeros in your answer. Place back the 2 zeros that you omit now. All right. So if you perform the multiplication for this, right, it will give you a 180. Okay, 15 times 12 is 180. Then you just need to add back the 2 zeros from here. All right, so that gives us $18,000. Now we can go on to find out how much he saved for 30 years. Of course, that will be 18,000 times 30. Likewise, when you do this multiplication, ignore all the zeros first. You can even ignore the 0 first. Okay, so 1, 2, 3, 4 zeros to ignore. You perform 18 times 3. 18 times 3 is 54. How many zeros to put back? Just now we counted 4, right? 1, 2, 3, 4 zeros to put back. Simply add back the 4 zeros, and that would be your answer. So it will be $540,000. All right. Okay, question 10. So Ali and Bob were at a carnival. Ali had this much tokens. Ali has 3 times as many tokens as Bob. And Ali gave some tokens to Bob. All right. And at the end, Ali and Bob had the same number of tokens. How many did Ali give to Bob? All right. So this question, actually, there are two methods to solve this. Okay, so maybe I'll just quickly show you the first method first. So if you observe this question, we call this an internal transfer question because Ali is giving to Bob. It's just within the both of them. Okay, so in the internal transfer question, we know that the total stays the same. The total tokens between the two guys never changes. Okay, so your method one, maybe let me just write that down here. Okay, so this is method one, yeah? So method one, I will use before change and after to show this, to illustrate this whole thing. Okay, so let's do the before first. So for before, Ali has 25500, whereas for Bob, now for Bob, you need to calculate out because Ali has 3 times of Bob. So that means Bob is lesser, right? Okay, so you have to divide by 3. Okay, so let's do the division. So if you perform the division, that would give us 8,500. This is the before information. Now let's go on to show the change. So Ali is giving some to Bob. I don't know how many he gives, so minus question mark. Bob is receiving, so plus question mark. All right. And at the end, both of them have the same amount. Same amount, just draw a 1 unit model for each of them. Good enough. Okay, and we agreed that yes, the total between both of them never changes because this is an internal transfer. All right, so since it's total unchanged, I can work out the total here. All right, so if you work out the total here between the two guys, that would give us 34,000. Okay, if you add these two numbers, 34,000. Now that means the total at the end will still be 34,000. So the total at the start is 34,000. At the end also no change, 34,000 because they're just giving one another only to each other. All right. So based on this model, notice that now we can find out what's the value of 1 unit. So simply divide by 2. Okay. That means it's 17,000. So this will be 17,000. All right. Then from here, you can simply use any one guy to find out how many Ali give to Bob. So let's say if I use Ali, can you see Ali at first? Okay, Ali at first has 25,500, and Ali gives some away such that Ali in the end has 17,000 in the end. All right. So simply use the 25,500 minus the 17,000 to find out how much he has given, and that will be 8,500. So this is your answer for the first method. Okay, I will show you method 2. All right, so both methods are fine. Method 2 is if you use the model way. Okay, so if I were to draw a model for this, at first I know Ali has this much and Ali has thrice of Bob. So 3 times of Bob means I can draw Ali at first has 3 units. Okay, and Bob has 1 unit. And what I do know so far is that Ali had 25,500 tokens. So this whole stretch is the 25,500. Okay, and Ali give to Bob such that at the end both of them have the same. So if you study through the model, how do I know how much he has to give to him so that they will both be the same? Okay, so you notice that in order for them to be the same, Ali has to give 1 unit to Bob. So let's shade off the last 1 unit. So this last 1 unit will be transferred to give to Bob. Do you notice that they are the same now? The moment he transferred that? Okay, notice that the white models, Ali now has 2 units after giving away. Bob now also has 2 units. So your answer lies in the shaded part that he's giving to Bob. So actually that shaded part essentially is just 1 unit, right? So if that's just 1 unit, notice that it's actually just 25,500 divided by 3. So that 8,500 is what he gave. So this is your answer. Okay, so modern method here, of course, involves lesser steps. All right. Okay, let's go on to question 11. A room measures 3/4 meters by 6 meters. Find the area of the room. Express your answer as an improper fraction in the simplest form. So when they say room measure this by this, all right, usually this is the length, this is the breadth. Okay, and both are in meters, so don't worry if you see a fraction there. So long as it's shown in meters, just take it as if it's like a length on its own. You don't have to think too deep into the fraction for now. All right, so they ask us to find the area. So based on our area and perimeter knowledge, we know that to find the area of a rectangle, we simply have to take the length times the breadth. So in this case, simply is your 3/4 meters times your 6 meters. Okay, so fraction multiplying by a whole number, we have discussed it earlier also. Remember 6, you can rewrite it as 6/1. It's optional. If you don't write 6/1, also can. I leave it to you. All right, then check whether you can do the diagonal cancellation. So 3 and 1, okay, 3 and 1 at this point, I think is nothing to cancel, right? If you look at it diagonally, all right, but if you look at 4 and 6, I'll highlight this, 4 and 6, we can cancel something. Both have a common number to cancel away. All right, so 4 and 6 both can divide by 2. So if this divide by 2 becomes 2, 6 divided by 2 becomes 3. Okay, so finally now you can multiply them together like this. Okay, which will be 3 times 3 is 9/2. And since they want it as an improper fraction in simplest form, so there you go. This is my improper fraction in my simplest form. Okay. Question 12. So Ming had some cookies at first. He sold 6/7 of the cookies. He then baked another half of what he had originally had at first. He had 1,512 cookies at the end. How many did he have at first? Okay, so this fractions question, first you have to understand the significance of the numerator and the denominator in the two fractions first. So I'm going to go through this slowly. I think this is important. We have to dissect that and break that down first. Okay, so let's understand what is the 6 about first. All right, so he sold 6/7 of the cookies. So simply the 6 units is what he sell, the sold. Correct. The keyword, the verb in front would give you a strong hint on what the 6 represent. Now, 7. What's the 7 about? So 7 units, they say 6, he sold 6/7 of the cookies. Usually I use the word of the something something behind to help me understand what the denominator represents. Okay, so of the cookies means the whole thing at first, the cookies at the start. All right, so the 7 units basically is your total at first. Okay, so all these notes good to write down so that you will have an idea of how to continue later on. Now he then baked another 1/2 of what he originally had at first. So he then baked another 1 unit. So this is what he newly baked. Okay, I'll just bring the word newly baked. So again, you see the verb that's in front of the fraction. He then baked. This word tells me that the 1 unit is what he newly baked. Okay, and what about the 2 units? Okay, so of what he originally had at first. So whatever is originally at first is your 2 units here. Okay, now why am I emphasizing the importance of this is because this will help you understand whether you are able or allowed to make the denominators the same. So if both denominators represent the same thing, they both have the same meaning, then okay, you can safely make them the same. But if they don't represent the same thing, okay, if the denominators don't represent the same item or same group of objects, then you cannot make the denominator the same. All right. So if you look at my denominator, 7 is representing at first, 2 is also representing at first. So can I make denominators the same? The answer is yes, you can, because they both represent the same thing, which is the at first. All right. So this 2 and this 7, no problem. Okay, both represent at first and at first. All right. So I'm just going to go on to convert that first. So 6 over 7 will be common denominator with 14, right? So 12 over 14. And of course, half will be 7 over 14. Okay, so bear in mind, this is what was sold. This is what was newly baked. Okay, now, so I need to somehow figure out a way to find out how many units is the 1,512 cookies. Okay, so I'm going to first list out, say, at first, how many units are there? So it's a bit like a before change after concept here, because there are two changes here. First is he sell, second is he baked. Okay, so two changes here. So I'm just going to list them all out first. So at first, he started off with how many units? The denominator will tell you so. So the new denominator, 14U, will be the at first. Okay. Now after that, what did he do? He sold something, right? So he sold 12 units of cookies. You cannot use 6 really, must use the new fraction here. Okay. Then the newly baked is how many? Newly baked is 7U. Alright. So now with all these changes, you can calculate out in the end how many units are left. Okay, so you start off with 14U. You sell 12U means lesser by 12, right? And what you newly bake is another 7U. So this is a plus 7U. You bring it another 7U. So if you do the calculation for this, you will end up with 9 units. All right. And this means your 9 units here will be the 1512 at the end. Okay, so you see, this is how we link this up, link this back to the 1512. Of course, work out 1 unit. Okay, so 1 unit will be 168. Once you have 1 unit, always reread the final question. They want how many at first? So remember, at first we have our 14 units here. So simply finding 14 units. Okay, and that gives us 2352 cookies. Okay, so that would be the answer. Okay, the last question, question 13. So the sum of the perimeter of two different squares is 40 cm, and the difference between the area of the two squares is 40 cm too. So find the length of the larger square. Okay, so right now they have given us sum of perimeters, difference in areas. We have two shapes here, okay, two different sizing, two squares but of different sizes. Sum of perimeters and difference between areas. We know nothing about the length, right? We know nothing about the length nor the breadth. Okay, so how do we go about solving this? So for this question, you have to do a little bit of trial and error in order to get the answer. Now, but for of course, for the trial and error, right, it's not just saying you randomly begin with a random number to begin solving. Okay, so every trial and error question, usually there will be a catch and a systematic approach into doing the trial and error, so the guess and check. Okay, so what I'm going to do is since they have given us the area, the difference between the area of the two squares, which is 40 in this case, this difference will be a good starting point. Okay, the area will be a good starting point to work with. All right, because area would have to involve square numbers. So what are square numbers? So square numbers are numbers like 1, 4, 9, 16, 25. Okay, all these numbers, they basically have two factors, two same factors that multiply each other to give all this. So for example, 9 has 3 times 3. 16 is 4 times 4. 25 is 5 times 5. That's why all these numbers are called square numbers. Okay, so I'm just going to begin by using the small square first for a start. So area of small square. All right, and I think we can begin with 1 first. So let's say the small square is 1 cm side. That means 1 times 1, the area will be 1. All right. Now, since the difference between the areas must be 40, that means the larger square must have an area that's 40 more than the one here. All right, so simply I have to add plus 40 to get the area of the big square. Okay, so now I'm testing out. So 1 plus 40, the area here is 41. Now, think about it. If my big square has an area of 41, okay, would this even be possible? How to know whether it's possible? Remember, areas of squares have to be square numbers because they are squares. Okay, that means the length, if they are squares, means the length and the breadth must have the same number. So is there any number times any number, and both must be the same numbers that multiply together to give us 41? Is 41 a square number? All right, so this is not a square number. So I cross this out. Okay, yeah, 41 is not a square number. So then I move on to test another one, which is 2. 2 times 2. So let's pretend that small square has a length of 2 cm. The area would then be 4. Okay, and the bigger square must have an area that's 40 larger than the small square. So plus 40. So 4 plus 40 will be 44. Now again, think about whether 44 is it a square number. Okay, so 44 is not a square number. There's nothing that I can multiply for two same numbers to give me 44. So that's out. Okay, let's go on to try 3. So 3 times 3. 3 cm side of the small square. So 3 cm side would give us an area of 9. Now I plus 40 to get to the big square area. So 9 plus 40, 49. So is 49 a square number? Alright, so thank goodness 49 is actually a square number, yeah? So this will be possible. Definitely this. Okay, we will consider this. So 49. So now the question is asking for find the length of the larger square. All right. So if you want the length, okay, so right now we haven't confirmed yet. Okay, I haven't be sure whether really is it this result of 9 and 49, because later you still have to check using the sum of the parameters. Okay, so later we still have to deal with that. All right. So let's find the length of the bigger square, assuming that 49 is really the correct area for the big square. So that means I have to show 49 equals to something times something, right? What are the two blanks? Okay, so the two blanks will be 7. All right, that means the bigger square has a side of 7 cm. Now with this, we can now finally test out the parameters. So parameter of small square first, let's do that. Okay, so for the small square, all right, so for the small square here, each side of the, assuming this is correct, okay, let me just highlight this, assuming this result is the correct one, all right, that means the side of the small square will be 3 cm. So perimeter means there are 4 sets of 3 cm, right? 4 times 3 cm. Okay, 3 plus 3 plus 3 plus 3. So perimeter is the outline, the outside of the shape. All right, next will be the perimeter of the big square. So using the 7 cm side, 7 times 4. Now let's check. We want sum of parameters. Okay, so if you look back at this, sum of parameters will be 40 cm. So let's test that out. So sum of parameter using the 12 and 28. If you check this, you realize that yes, indeed, it gives us a sum of 40 cm. All right, which actually fulfills the condition here. So whatever we have tested out, yes, sum of parameter fulfills the condition of 40 cm. And yes, the difference between the area 40 cm square, we also fulfilled that also by doing our test here. So that means that the length of the larger square, indeed, it will be the 7 cm. So our answer would be 7 cm.